In the video on the acceptable use policy, we discussed the difference between login nodes and compute nodes. You access the cluster through a login node using SSH, and you access the compute nodes from a login node using LSF. So now that you're logged in, where do you put your stuff? The login nodes and compute nodes are both attached to a shared file system for storing and manipulating data. To understand the proper use of the file system, or in other words, where should you put your stuff, we have to replace the simplified sketch with something a little bit closer to the real thing. Here is a more accurate diagram of the HPC storage. Even though this is still an oversimplification, it's a lot to take in at once. Let's examine the file system piece by piece. And just so you have a reference point to look at later, we'll start with the storage documentation on the HPC website. Go to the HPC website and click Storage, Directory Locations, and Size Limits. The Data Storage page goes over the storage options for Henry2. The main types of storage include the home directory, the scratch directory, and mass storage. For each storage type, the website lists location, quota, and backup policy. In other words, where is it, or what is the path to the directory? How much stuff can I store in the directory? And if I store my stuff there, is it going to be saved? If something happens to my files, can HPC get them back for me? When a user logs in to the HPC, the first thing they see is their home directory. So let's start there. Each user has a home directory. At 1 GB per user, this space is pretty limited. Each user also has access to a scratch directory located in Share. There are 10 terabytes of scratch storage available to each project group. The home directories are necessarily small because HPC has to make regular backups of these files. The directories in home are backed up daily. The scratch space stores massive amounts of frequently changing files. HPC cannot back that up. Not only is it not backed up, files that have not been accessed in 30 days will be deleted. When you move your workflow to HPC, you'll save your scripts and your code to the home directory. For everything else, you're going to use the scratch space in Share. You're going to copy your input files to Share. You're going to run the application in Share, and all your results are going to be written to Share. You'll also run any analysis or data visualization scripts on Share. After your job is finished and you're done with the post-processing, you'll transfer all of that output back to your local machine for safekeeping. If this sounds like what you want to do, if it matches your workflow, you can basically stop right here. But if you're eyeballing the tiny size of the home directory, or you're looking at the big trash can next to the scratch space, you should probably go ahead and keep watching. Unless you're just doing some quick testing and development, you'll want to make sure that your code, executables, and scripts are all backed up. So far, we've seen that only the home directory is backed up. But sometimes an application is just too big to fit in that home directory, and that isn't just limited to the giant community codes. It could be that you need to install a bunch of R libraries, or maybe your Python environment is just getting too big. Sometimes you have some code that can fit in a home directory just fine, but your whole group needs to use it. You really do not want to host group applications from your home directory. The HPC accommodates all of these scenarios by providing disk space for user applications. So if you get to the point where you or your group needs this kind of space, go to the HPC software page and follow the instructions to request a directory for user-maintained software. User-maintained software directories are located in user-local user apps. The space on user apps is limited and it is not intended for storing large files, but it is significantly larger than a home directory and it is backed up. So there's one more thing I haven't mentioned yet about storage, and we need to discuss it in order to avoid making some common mistakes when using the user apps directory. In addition to knowing the location, quota, and backup policies, we have to know the accessibility of files from the different types of nodes. Access in this case just means read or write access. Can a certain node read or write to a certain file? We already know that you can't access a compute node from the campus network. First, you got to log in to a login node with SSH, and then from the login node, you can use LSF to talk to a compute node. There's actually no communication between the outside network and the compute nodes. The campus network can't access a compute node, and a compute node can't access the campus network. Just as there are different types of network access rules depending on whether you're in a login node or a compute node, there are also different types of file access rules. For example, a compute node cannot write to the user apps directory. The compute node can read from user apps. It has to be able to read from user apps to run your application. But a compute node does not have write access to user apps. Your executable lives in user apps, but you should be submitting the job from share. If you submit a job from user apps, it won't work. But worse than that, you will have no idea why it didn't work. You won't know why it didn't work because you won't get an error file. It makes sense. LSF can't generate an error file if it isn't allowed to write one. So once again, always submit your jobs from share, but also recall that the share directory is not backed up. And while it's true that nothing is deleted on purpose from share unless it hasn't been accessed for 30 days, it is still the case that if the file system goes down, we may not be able to retrieve your stuff. Stuff on share is not backed up, and when it's gone, it's gone.
We are pleased to introduce to you Research Storage. Every researcher at NC State can get a research storage allocation. Also, principal investigators automatically get additional storage for each new grant awarded. Check the storage documentation for more info.